Okay, so our next chapter is over the linear regression. The linear regression is the next step in our process. Following this, we did a hypothesis test. In the hypothesis test, we can only check for significance, for statistical significance. Now we can use a linear regression, which we can use to predict actual changes. We can predict changes in the independent variable. In the dependent variable is related to changes in a dependent variable. It's the first time that we'll be able to do this, and we'll use what should be familiar to most students is the line formula, and the line formula is this formula, which is here, and this formula is just y is equal to the y-intercept. That is where the line crosses the y-coordinate at 0 times the slope and our individual x. So what we're trying to do is we're trying to get back to this formula, right? So the y is always a dependent variable. The a is always the intercept, and this is always a slope. So what we can do is we can actually predict changes, and what we will do is we'll use this table here as our example, right? So this is a fictional data set which examines a husband's contribution to housework per children, right? So if we look at this data set, we want to make a prediction. We want to predict how many hours of housework a husband will perform if he has a certain amount of children. And for us, we're going to say 6 children. So how many hours of housework will a husband perform if he has 6 children? And we can look at this data in this table, and we can identify our types of variables, right? So we know that the number of children is our independent variable. That is our x, right? And we know that hours per week a husband spends on housework is our dependent variable. So we got our independent variable here, and we got our dependent variable here, right? And what we're trying to do is we're trying to get to this formula, right? Okay, so the way that we get to that formula is we have to determine 2 things, right? We have to find the y-intercept, and we need to find the slope, right? So we have a couple of formulas for figuring that out, right? We have the slope formula, which is here, and we have the y-intercept formula, which is here, right? So if we look at this formula for the slope, and this is a formula for the slope, we can look at the numerator and the denominator, and we know that we have to deconstruct this into a table. So we have a table here, and in this table, what we need to do is we need to deconstruct everything that's related in our table, right? So in the table, we have in the numerator, we have this, right? And this is simply 2, right? And we have this, and this is 3, right? And we have this, and this is simply 6, right? So if we deconstruct everything that we have to do in a table, we can put it into our chart. And we know that the uppercase sigma means the sum, right? We got that on both sides, right? So we've deconstructed our table, right? So what we need to do is we need to figure out the slope first, and then we can use the slope as we add it to our y-intercept formula to figure out the y-intercept. But the first thing we have to do is we have to build a table, right? So let's build our table. So as we build our table, we've listed all of the independent variables in 1, right? And we listed all of the independent variables in column 3, right? And what we need to do, if we look back at this formula, it has the mean of the x's and the mean of the y's, right? So the first thing we need to do is we need to figure out the mean of the x's and of the y's. We've already done it in the table, and what we know to do that is all we would do was add all of these up. So we'd add 1, 2, 2, 3, 3, 4, 4, 5, 5, and we would divide it by the number of observations, right? And if we did that, we should get 2.67. And we'll do the same thing for the y's, right? So once we've done that, we need to continue building our table, right? So this was step 1 and step 3. In step 2, it simply says that we must subtract each x from the mean of x. So for this first a, it would simply be 1 minus the mean of x, which is 2.67, which would equal negative 1.67. And we just go down the line because these are the same, and we'll see the same thing for the 2's, right? So it'd be 2 minus 2.67 here, and we'll see that that is a negative 0.67. And we'll go all the way down the line for each one of those. And we'll do the same thing for the y's. So we calculated the mean of the y's at 3.33. And we'll subtract each one of our observations from the mean of y. So this first one would be 1 minus 3.33. This would be 2 minus 3.33. And what we see is we get for our first one is negative 2.33. Our second is negative 1.33. And we'll just go down the line with each observation. Okay. So once we've calculated our column 2 and our column 4 for each one of our x and y's, then we move on to our next step, which is column number 5, right? And these are all part of the formula, right? So we know that this is simply the numerator of the formula, right? And the numerator of the formula says that we should multiply these two together, right? So what this basically means is that we're simply multiplying every observation in column 2 by every observation in column 4. So our first one would simply be negative 1.67 times negative 2.33, right? And if we multiplied those two together, we would get 3.89, right? And our second one would be negative 1.67 times negative 1.33, which would give us, because these are two negatives, when we multiply them together, would give us 2.22, right? And we just go down the line, right? And our next one would be negative 1.67 times negative 0.33, right? And that would give us, for our third observation, of 0.55, right? And we would just go down the line, right? And we would do this for each one of its corresponding observations, right? And this is all part of the formula, right? We're just following the formula. And the formula says, has one more step, right? So we have this step in the denominator, right? And the denominator says that we have to square the difference of the means and our x's, right? And that is step number 6, right? Step number 6 is pretty simple. All we're going to do is take the square root of all the observations in column 2, right? So that is basically, if we looked at this table here, that would basically be negative 1.67 times negative 1.67. And that would give us 2.79 if we rounded it up, right? And the same thing holds because this is the same thing. So that would just be the same going down. But when we got to a different one, let's say this one, negative 0.67. If we square that, that'll give us 0.44 or 0.45 if we round it up, right? And we'll do this for each one of these going down to the last observation, right? And once we do that, once we get to column number 6, we have completed everything in the formula, right? We've done this, this, and this. We've even multiplied these two things together, right? But what we haven't did is we haven't incorporated these uppercase sigmas, right? And these uppercase sigmas, they simply mean to sum, right? So the formula says that for column 5 here and column 6 that we need to sum. And what we do is we're just adding all of these up. So we're going to add all of these up and we're going to report it here, right? For each one of them, right? If we do that, if we add them all up, we'll see that this equals 18.32 and this equals 26.68, right? So what we can see now is that we've completed every part of the slope formula. So now we can actually start to put these into the formula to actually calculate. So now we can just start putting these into the slope formula, which is here. We'll see that we've done everything in the numerator, right? This is the numerator. And that is basically column 5 is the whole numerator. So that means that is simply 18.32, right? And that we've done everything in the denominator, right? And that is simply column number 6, right? Which is here, right? So that just means that this is 26.68, right? And if we do the math, we know that our slope is simply 0.69, right? So we have calculated the slope, right? And since we've calculated the slope, we have the means to plug that information into the y-intercept formula, right? Because the y-intercept formula required the slope, which is here, right? We've already found the mean of x and the mean of y, right? They're right here. Both of those are there, right? We did that initially when we built the table. So now we can calculate the y-intercept, right? Just by plugging the information that we have, right, into the formula, right? So we know that the mean of y is 3.33. And we know that the slope is 0.69. And we've already calculated the mean for the x's, so we know that is 2.67, right? If we do the math, we know that everything on this side of the equation is 1.84, right? And so we know this is 3.33. So if we continue on, if we just subtract these two, we get a y-intercept of 1.49, right? So now we have the slope, which was this 0.69, and now we have this the y-intercept. Now we can calculate the actual regression line, right? And it's key that we understand that the regression line is part of our answer, right? So if you're asked to report the regression line, it looks like this. The regression line, if we write it out, is y-intercept plus the slope times the x, right? So what we have is we have this line. This line is 1.49 plus the slope we figured out, which is 0.69 over x, right? This is the line formula. But we want to take it a step further, right? Because we were asked specifically what is this Y, or what are the hours of housework when a husband works, when a husband has 6 children, right? So we can define how many hours of housework, right? When we make this X 6, right? So if we make this X 6, that simply means we just substitute everything into the equation, right? 1.49 plus 0.69 times X. And in this case, our X is 6, right? So we can erase this X and we can just write in the 6, right? And if we do the math, it'll come out to be that a husband will do 5.63 hours of housework per week if he has 6 children from our fictional data, right? And we can substitute almost anything in here, right? So what if a husband has 7 children, right? It'll be 1.49 plus 0.69 over 7 here, right? And if we do the math, that'll come out to be that a husband will do that didn't come out right because my pen didn't want to work right. So we'll disregard that. But what will come out to be that Y will be 6.32 hours of housework if a person has 7 children. I don't know why anybody would have 7 children, but let's say they did. Okay, so we'll move on next to looking at the goodness of fit of this model using what's called